This is a review lesson on solving systems of linear equations, and this is from grade 10. We're going to look at how to solve them graphically, by substitution, by elimination. This outcome is RF9 from grade 10, and if you are using the Pearson textbook, that was chapter 7. Just a quick review about solving a system. We have 3 possibilities for an answer. So if I have 2 lines, like so, they meet at a point. This is the solution. So this has one solution. It's the point of intersection. Next scenario, line like this, and I'm really just going to clone this so that I have the exact same line. I'll just color it so you can see it in a different color. In this particular case, we have another special case that we have, and this has no solution. Why does it have no solution? Because there is no point of intersection. These 2 lines are parallel. And there's no point of intersection, there's no solution, because solution is where the 2 lines meet. We have this third case. Here's a line, and I'm drawing another line. I don't know if you can, may not have done a great job on that one. Let me just undo. I'll do what I did there before. We'll clone this because we have another line, and this line actually is going to be directly on top of this first line. If I draw the line and I lay it right on top, what is the solution? Well, every point here is common. So we say that there's infinitely many solutions. There's my shorthand for solutions. And we use a shortcut maybe, or the symbol here for infinity. Every point's common, and there's an infinite number of points. So no matter which method we use to solve a system of linear equations, one of these 3 will be the solution. Well, let's look at this algebraically. If I was to, I can do it graphically by graphing each line on the same graph paper, and where they meet is the answer. But let's look at it algebraically. Substitution is probably the one method you're going to see the most, especially in your science classes, because they lend themselves nicely to this form. And if that's the case, if you're going to use substitution, I would do it if I had a coefficient that of 1. So this x has a coefficient of 1, and the y has a coefficient of 1, or -1. So let's solve for either one of those variables. So x is equal to y plus 4. So that's very simple to have it in that form. If you did solve for the y, make sure it is positive y, not the negative y. Maybe I'll show you with that. All right, so if I did that, I have negative y is equal to negative x plus 4. You need to make it so it is y is equal to x minus 4. I'll carry on from here. So as long as you have solved for one of the variables that had a coefficient of 1, it's easy now to do a substitution. Just like you would in basketball. If someone needs to be subbed into the play, they find out who they're guarding. Now they go into the game in their place, and that's who they're guarding. They're taking their responsibilities. This is the same thing that's happening, and then they can sub back in at the end and switch roles at once more. So here, wherever there is a y in this second equation, I'm going to be putting in x minus 4. So 3x plus 2 times y. So it's going to be times the x minus 4 is equal to 7. And we just continue with the math. So 3x plus 2x minus 8 equals 7. 5x is equal to 15. X is equal to 3. That's not the final answer. The final answer is the point of intersection. So if I have x minus 3 for x equals 3, I want to find out what the value of y is. So y is then going to be equal to 3 minus 4. Y is equal to negative 1. For my final answer, it is a point. The coordinate point 3, negative 1. And this is the final answer. And that tells me that this is the point where these two lines meet. Well, let's look at this example. You may want to pause and try it on your own. I'm going to use substitution. You could use elimination, but I'm going to use substitution because I do have a variable that has a coefficient of 1, so I can use that. I'm going to solve this for x, so x is equal to 2y plus 2. That means when I'm dealing oh, pause here for a moment. So I'm going to use this equation, the one I didn't use yet. So 3x plus 4y minus 16 is equal to 0. Wherever there is an x, I'm going to put in 2y plus 2. So this is 3 times 2y plus 2 plus 4y minus 16 equals 0. Be careful with your details. Just make sure that you take your time and be careful to make sure you're doing your substitution correctly, putting in your parentheses. Expanding here, distributing through the bracket, we have 6y plus 6 plus 4y minus 16 equals 0. I get 10y is equal to 10, so y is equal to 1. That's okay, we can have it for y. What I'm going to do is put this up in here, and I'm going to solve for x. So x is equal to 2 times 1 plus 2, so x is equal to 4. My final answer is a point for 1. Why don't you give this one a try and see what you get. Well, if you're like me, I'm saying, okay, this is good for substitution. So I say y is equal to negative 3x plus 4. So 3x plus 2y is equal to 8. 6x plus 2 on 2. A negative 3x plus 4 is equal to 8. So I have 6x minus 6x plus 8 equals 8. Something strange happened. 6x subtract 6x is 0, and I am left with 8 equals 8. And if I subtracted 8 from both sides, I get 0 equals 0. I have my left-hand side equal to my right-hand side. And this is a special case. This is telling me, therefore, that there are infinitely many solutions. All the points are common. So there's a special case, and that's going to come out algebraically. So when the left-hand side equals the right-hand side, your variables are canceled out. They're adding to give you 0. Then we have this problem, or this scenario happening. And I'm going to look at elimination. Just to remind you, elimination means we want to eliminate a variable. You're going to add two equations together to get a 0, is what's occurring. So right here, if this is equation 1 and this is equation 2, I can just quickly just take equation 1, add it to equation 2, and we'll see that these 4's are going to cancel out. So you're left with 8x is equal Um, excuse me, negative 16, x is equal to negative 2. Once I have that, I can substitute the x into one of the two equations. I'm going to pick number 1, and I'm picking number 1 because the numbers are smaller, so I can do the work in my head easier. So this is negative 6 plus 4y is equal to 6. 4y is equal to 12. Y is equal to 3. Final answer, the point negative 2, 3 is the point of intersection. Example 5. First of all, they're not lining up nicely. My x's and my constants and my y's do not line up. So the first thing I would do is to line them up. So I tend to be a creature of habit. I like having my x plus my y equals my number. So if I was to rearrange my equation to do that, I'd have 5x minus 6y equals 10. And that's for the first equation. And my second equation would be 5x minus 9y is equal to 10. And I want to eliminate a variable, and I see those 5x's right there, but all I need to do is to subtract. Or another way to subtract is add a negative. So what I'm going to do is, this is equation 1. Let's call that equation 2. So I'm taking equation 1. Sorry, not take. Yeah, let's do it this way. Taking equation 1 and I'm adding it to equation 2 that I have multiplied by negative 1, which is doing, what does this do? This does a sign change. And then I'm going to add, right? That's allowing me to do the add. So I would have 5x, well, I can do that all in one step here. Maybe that might be easier. So a sign change, that's a negative 5x plus 9y, subtract 10. That gives me a 0. This gives me a 0. So I have 3y equals 0. Well, y equals 0. I caution you, that is okay. You can always have a 0 y coordinate. That is telling me that it's on the x-axis. Well, where on the x-axis? So let's take our equation. 5x is equal to 10 plus 9y. 5x is equal to 10 plus 0. So x is equal to 2. So I have y is equal to 0, x is equal to 2. That point is a point 2, 0. So again, I'm going to caution you, you're going to see sometimes where you're going to have x equals 0 or y equals 0. Use it. It's a number. So we're good. We're either going to be on an x or a y axis. Well, again, using an elimination, I could use substitution, but I'm wanting to practice elimination. I can't just change a sign and add to get my variables to cancel out. But I can do something to equation 2. So let's say that equation 1 and equation 2, but I took equation 2 and I multiplied it by a negative 2. That's going to do a sign change as well as change those numbers, so then I'm going to have them the same. So this would give me 4x minus 2y equals 0. And my second equation would give me negative 4x plus 2y is equal to negative 6. Something strange happens. That gives me 0. That gives me 0. I get 0 equals negative 6. This is not possible. Nowhere does 0 equal negative 6. It's not possible. So if your left-hand side cannot equal your right-hand side, you have no solution. So the answer is therefore no solution. When your left-hand side cannot equal your right-hand side. That's what happens. So when both your x variables and your y variables cancel out, you need to check and see, is it a no solution or an infinitely many solution? Why don't you try this one on your own? Gives you some practice. Can you use substitution? No. Well, you could. Excuse me, you could. But it's going to make life very difficult. You're going to have fractions. This is a type of question that shows this is why we teach elimination, where my coefficients on my variables, there's not one that's a 1. But what can I do to make them the same? I see 4 and 6. I always kind of look at my even numbers. Can I make them both a number that can cancel out? So basically I'm asking myself, is there a lowest common multiple? I always want the smaller numbers. Well, if I take equation 1 and I multiply it by 3, I'm going to get 12x. If I take equation 2 and I multiply it by -2, I'll get a negative 12x. Oh, that's what I'm looking for. So 12x, subtract 12x, 0x. Perfect. So let's do that. So we have 12x minus 15y is equal to negative 72. And that gives me negative 12x minus 14y is equal to negative 44. So we got some big numbers here. So this gives me that's a 0, so negative 29y is equal to negative 116. And if I divide both sides by negative 29, y is equal to 4. So now I take 4x minus 5y equals negative 24. 4x minus 5 times 4 equals 24. So 4x. Did I check my signs there? Did I make a mistake with a sign? Yeah, I knew I made a mistake with a sign. There it is. It should be negative 24 here. So this is negative 20 equals negative 24. 4x is equal to negative 4. X equals negative 1. The answer is negative 1, 4. And that is the solution to our system. So I'm going to recap 3 possibilities. So when I'm looking at one solution, my lines are going to meet somewhere. They can have the same slope or they can have they can't have the same slope. They can have the same direction of lines. They have to have different slopes. So here we have one solution, so we have one point of intersection. Our slopes are different. So as long as the slopes are different, you know there's going to be one point of intersection. Okay, the other option is a no solution. And in a no solution, I've got parallel lines. The easiest way for me to show you is to do this. Okay, so I have parallel lines. Well, what are some classifications on that? Well, we know that our slopes are the same. Parallel lines, the same slope. From grade 10, we realize that. Our y-intercepts are different. Algebraically, we find that the left-hand side cannot equal the right-hand side. And the answer for this is no solution. Well, what does infinite solutions look like? Well, infinite solutions, oh, I just did the whole thing. That's all right. Well, is when that line, and I draw another line, and it's right on top of the first one. It's the exact same line. If that happens, slopes are the same. Y-intercepts are the same. Makes sense, it's the same line. Algebraically, the left-hand side equals the right-hand side. We have the same line. And we have the same line, all points intersect. And what do we say this is for an answer? This is infinitely many solutions. And this concludes our review of solving systems of linear equations.